Hello and welcome to Maths with Mr Amison. Today I'm going to be talking about the basics of vector geometry. So by the end of this video you should be able to answer this question here. So I'm going to start with how to add vectors together when they're in a diagram. It's called vector geometry. Now here I've got, this is the starting point. The vector u goes to the purple circle and the vector v goes to the red circle. If we think about u plus v and v plus u, we get this kind of thing, where if u plus v is u first, so you do the vector u first and then the vector v, so the resultant of u plus v is this vector here. Okay, not going from here to here, but doing u first and then doing v afterwards. If we continue, the vector v plus u, as you'd imagine, is very similar. You do the vector v first, and then you add the vector u. So the resultant here of v plus u is this, and it gets to the same place. If you think about it logically, u plus v gets us to this exact same place. So it doesn't matter what order you add vectors in, just like normal adding of algebra. If we think about subtracting vectors, things are a little bit different. If we have minus v, u minus v, then we have the vector v here going from the black circle to the red circle. Minus v is the opposite direction of v. So minus v goes from here to here. So if we're going to do u, then take away v, we go from here across u, and then as soon as we get to the end of u, we then take away v, which goes from here to here. This vector here is u, take away v, goes from this point to this point. If we think about v plus u, v minus u, however, v minus u is a bit different. V minus u, u is subtracted this time, so it's the opposite direction for u. And if we move the vector u up here, because it has to be at the end of vector v, because we're doing v first, v, then take away u, goes from here to here. Now notice that that vector here, v minus u, is exactly the same as this vector here. If you think about it logically, to go from here to here, we have to go along u in this direction. We have to go along v in this direction. That's the long way to get from here to here. So from the purple circle to the black circle, well, that's u in the opposite direction. That's minus u. Let's go from the black circle to the red circle. Well, that's v in the positive direction. So it's minus u add v, which is the same as v minus u. So in this diagram, we'll put that into practice. We're going to express each of these in terms of a and b. First of all, f to c. Now notice that a to b is a and b to c is b. There are many different lines in this diagram that can be represented by these same vectors. From the middle to c, for example, is the same as the vector a. From a to the middle is the same as the vector b. From f to e is the same as the vector b, and we'll get to each of those. But let's think about f to c. To go from f to c, we have to do this vector and then this vector. Well, both of those are the same as a. So f to c is the same as 2a. E to d would be the same as a. F to e, well, that's going along the bottom here only. Well, that would be the same as b. And a to f is a to f's a bit trickier. We don't have a vector, a named vector for any of these lines. So what we can do is figure out how to go from a to f in terms of a and b. Let's go from A to F, because we don't know this line. We do know the horizontal vector here, that's B. And we do know this vector here from F to the middle, that is A. So let's go from A to F. We need to go along B, and then we need to go the opposite direction of A. So it's B, take away A, to go from A to F. Alright. So with that in mind, you should be able to now have a go at this task here. I'm going to leave that with you. Thanks for watching. Keep doing your maths, and see you soon.